Hi there, my name is Bins, and I welcome you to a second video about Shapes.io, a cute factory-style indie game that I totally fell in love with within seconds of playing, where the goal is simply to extract source shapes from an infinite map, build some machines that can manipulate these shapes, such as cutting them up, rotating them, reassembling them, painting them, etc. In my first video, I essentially just awarded myself the world record on the fastest automated factory that you can build once you make it to free play mode. I managed to get from levels 27 to 127 in about 2 hours and a half, and I hadn't found any video that did better than that. So I basically just said to myself, you know what? I am simply going to shout out like, hey, I am the best, in a clickbaity way, as a kind of taunt or a challenge to other players to upload videos in which they do better. Now, to be fair, YouTube is the only place I've been looking for other contenders, so to speak, and I haven't found any videos. So if you find a video on this or another platform, please don't hesitate to rub it in my face that I am not actually the best. Well, I mean, you can tell me, but please be gentle. I have a soul and a very fragile ego. Anyway, before I continue, I'd like to mention that I'll be referencing the machine I made in my previous video quite a lot, so I'd like to invite you to go watch it first if you haven't already, as I'll be comparing a lot between that design and the new one in this video. Alright? Let me first connect up the signal coming from the hub to my machine for now, and then later I'll explain how my new machine works while we see it running in real time, okay? There we go. So an interesting thing happened. On my previous video, the one for which I claimed the world record, I got a lengthy comment by a guy named Zachary Smith with some compliments in it, but also some constructive feedback. And I replied, and then he replied, and then we started a conversation by email in which he shared his views on my machine. With some suggestions here and there, he explained his approach on the matter, shared some screenshots of his save game, and essentially it became what I feel was a very interesting and especially insightful disquisition. You know, an exchange of ideas between the two of us, and I must say, my eyes were opened quite a bit. Zachary suggested I work with smart color mixers and smart shape cutters in order to supply my painting modules with the correct input. And I objected. I was like, but in my machine, I have all the colors and all the shapes pre-made. The only thing I need to do to get them flowing is a simple filter that opens up. So how on earth is that going to be slower than when I have to still start cutting shapes and mixing paints only when I know which shapes and paints I'll need? And then the keyword dropped, the frame rate. I was explained that while the machine may be a bit slower in theory, the game will actually be faster. My mind was blown. It was thanks to this conversation I understood that the main enemy, so to speak, the main obstacle in my pursuit of the fastest automated factory is the game lagging due to a poor amount of frames per second. So Zachary explained that my machines, or rather my game, was tremendously slowed down because of the amount of crap I had on the map. When you have thousands of buildings and belts and wires and whatnot on the map, the game has to calculate everything. And the more it has to calculate, the slower it will process and the slower the game will become. By decimating the amount of buildings and belts on the map, you can bring the frame rate back up because the game can process everything a lot quicker, and that way you compensate immensely for the bit of efficiency you lose in the actual factory. The end result is that in practice, you will zoom through your levels a lot quicker. Now, I don't consider myself to be the dumbest person on earth, but sometimes I can be completely oblivious to some things, and this was one of them. I never even contemplated that the frame rate might be an aspect to factor into the equation. Now, in my defense, I'd like to say that it's not that noticeable at all if this is something you're not intuitively taking into account, and that is because when you start a new game, the frame rate is maxed out, but your belts and buildings are initially very slow, right? So on one hand, while you progress through the game and you place more and more buildings onto the map, the game does gradually slow down. But on the other hand, you're also constantly upgrading the various units so they become faster. And therefore, to the naked eye, or well, at least to mine, it wasn't apparent that the game was gradually becoming slower and slower. So that realization was huge. Now, at the same time, this realization also disappointed me a bit because I realized that measuring the speed of your machine in real, physical minutes and seconds is maybe not a fair way of measuring. Like measuring how fast a shark is by yeeting it onto a racetrack and yelling, "All right, shark, let's see how quickly you can run those 100 meters." You know what I mean? I feel like people who enjoy this game as well as other factory style games or just building games in general are structural thinkers with, let's be honest, at least some levels of OCD. And I feel like such people are mainly theoretical thinkers who conjure up a factory in their minds and then build that factory as to examine whether their ideas work out the way they'd imagined. And I feel like having this trade-off between how many items you can place on the map and how that amount is going to affect the overall performance of the game, that's not really where the satisfaction in this kind of game lies. Well, at least not for me. It kind of takes the fun out of it. I feel like if Shapes.io had a kind of in-game timer or stopwatch that would count in accordance to the in-game time, not the real time, then that would provide a fair measuring tool of how good, fast or efficient your make anything machine actually is. So, while in my previous video I proudly proclaimed myself to be the world record holder, now I feel like measuring in physical time is not a fair and therefore less satisfying way of measuring. So while this machine manages to level up roughly twice as fast as the previous one, I somehow don't really feel glory in proclaiming myself to be the world record holder anymore. So I am uploading this video mainly to explain the new concepts in this machine and to show it off for funsies, but as you can tell by the title of this video, it's less clickbaity as the previous one was. And that is, like I said, because I question the validity of time as an accurate unit of measurement. Even if you, let's enable the frame rate viewer for a minute. So you see that my current FPS, my frames per second, are hovering around 18, 19 frames per second. And even if I zoom out and I move around the map, this is usually going to influence your frame rate. So the exact same machine can perform better or worse depending on whether you are actually moving around the map. And so in that sense, it is not a fair comparison, right? So I felt like I needed to include this disclaimer into my video before we would have a look at the actual machine. So let's do that now, shall we? In the grand scheme of things, first of all, I had 4 machines before. Now I have only 2. And that is to cut back on, the amount of units and belts that I have on the map as to maximize the frame rate as much as possible. So I have only 2 machines, and that will in fact enable me to get to level 127. So the goal is still the same in that sense. So I have two machines. These machines are identical, and they have roughly the same setup as my previous machine. So I start off with a double painter array. So I cut each of the 16 quadrants and paint them, and then I feed them into different layers of stackers, where firstly 2 quadrants will be stacked to create half a shape. We had that before. Then half a shape is will be combined to a full layer. Let's wait until the next shape of the next level zooms along. There we go. So 2 half layers will be stacked to create a full layer, and then 2 full layers will be stacked to create a shape with 2 layers. These are layers 3 and 4. This would be layers 1 and 2. And then in the final step, that will just be merged, be stacked to create the final shape. Now, in this moment, we are working with shapes that have only 2 layers. So again, in the final step, this is bypassed. It will move through the middle here, and it will be output to the hub, right? So first the cutters, first the painters, and then the stackers in 4. Let's call it 4 levels. All right. My painting module is still roughly the same as it was before. No, hold on. We'll get back to the painting module. First, let's get back to Zachary. So in my previous machine, what I did was I had both the shapes and the dies ready to be output at any given time, right? So, and because of this, I had a massive amount of machines that would prepare the shapes and the dies, so to speak. So if you remember, or if you go look at my previous video, I had an insane painting array that would pre-mix the paints, pre-mix the dyes, so that I would be able to output any of, I believe, 112 belts of color in total at any given time. And the amount that took on the map, the amount of stuff that took, the amount of buildings on the map was truly insane. And then for the shapes, I had something similar. I had all the shapes, all the quadrants ready to go at any given time, right? So, and thanks to Zachary's input, I told him I would use his machine for inspiration, and between you and me, I just shamelessly copied it, basically, right? So I told him I would use it. I told him I would give the proper credit. So this is all his doing. This really blew my mind. So what he did was he had a shape on the map that contains the 4 different possibilities, you know, a circle, square, star, and pinwheel. It contains 1 corner of each. So find one of those shapes on the map and then run that into this machine. So what this machine is going to do is it's going to cut everything up, and then through a filtering mechanic, it's only going to let through the quadrant, the shape that we currently need, right? Now, for any of these quadruple of cutters, you get a 1/4 of a full belt's worth, right? However, this equals out because you do this 4 times in a row, and in fact 1 belt is enough to power 16 cutters, and in the end you will get to a full belt of your quadrant again. Now, for now, let's not look at the paint. Let's only look at the shapes. So what this does, and this is the true genius of it all, is he worked with a storage supply, and I shamelessly copied this mechanic. So what it does is when you have a change of shape, this machine is going to need some time to get to a full belt, right? And in the meantime, the filters here are opened up, and in the meantime, your full belt is already supplied from the storage. and this will replenish. And that is the genius part of it. So what he does is, you can see this cascading thing where the filters detect what is coming in, and if it's not the desired shape, if it's not the desired shape of the quadrant, then it will just move through this cascading thing. Here we see it with the star quadrant, right? It will just cascade through, and these storages, they will actually replenish themselves with the surplus that you get from the machine when it starts outputting a new shape. This is pure and utter genius, and I really have to credit him for that, because I would have never come up with something like this. I would have never thought about this mechanic. It's really, I find it extremely elegant the way that works. So, you know, hats off to that. I just shamelessly took it, put it in my machine, and it works really well, right? Now, and then for the painters, for the colors, sorry, for the color mixer, this is a smart color mixer, and that is even more brilliant if you ask me, because here is where the cascading bit really comes into play. So you have this smart color mixer, and the way this is set up, you only need 3 incoming belts, you know, for the primary colors, and then with a rather complex wiring mechanic, which we will get back to. These shapes will move, these paints will move through the smart color mixer. And here is the thing. It will take some time for your machines to reach a full belt of paint output, right? But if you work with the double painters, you will probably know that you actually only need half a belt of dye input, right? So again, this same mechanic applies, that you need some supply in these storages to start off with, and as soon as you get a new shape, you know, in this case it's gray, so it doesn't really show it off much. But here, for example, we have the purple filter that's open, and because your output is only half a belt's speed, your machines will actually back up, and your storages will actually fill up rather than deplete. This is the genius part. So in this time, and we see this here now. So now the yellow belt opens up. The machine is doing its thing. We have the yellow dye now coming in, and we'll actually have we will actually have a replenishment of this yellow dye. So we only needed a little bit to immediately kickstart a full belt, and whatever we lost is now being replenished. And we will likely see this soon, that when this hits 5,000 units, it will actually overflow into the trash can. Here we go. So now we have a full storage, and the surplus is just thrown overboard, and it will move straight through the trash. So that is really, really a brilliant move, if you ask me. So then we go to the painting modules. I have 16 painting modules again, just like last time. It's essentially the same concept. I just tweaked some belt parts a little bit as to make it a bit more efficient. So what I did, first of all, is I kind of used this pressure distribution mechanism I briefly talked about in my previous videos. I used that as well here. So rather than moving all your shapes onto one line and passing them in serial fashion, let's call it serial fashion versus parallel fashion. If you move it in serial fashion through all your machines, you will need a little bit more time to achieve a full belt, rather than when you split your shapes or your paints or whatever you have running across your belts. When you split that up first, distribute it first and then try to distribute it as evenly across your machines as possible. So I did that here. I split up my shapes. Half of them will move through, will move onto the bottom belt, and then half of that will move back to the upper belt to supply this machine as much as possible. You know, and this way it's a little bit faster than when you just have the one belt moving through your machines, through your painters, one after the other. Right, so it doesn't save a lot, but it saves just a bit. And then we get to the stackers, and the stackers are actually they're quite a bit different compared to my previous machine. And the main difference is that they are now a lot more asymmetrical than they were before. And this has to do with the fact that in my previous video I rambled on a lot of minutes about how you have to try and reduce the amount of superfluous shapes that you get whenever you go up a level. So whenever you have a change of shape, due to the way Shapes.io works, your superfluous shapes will still have to move through your processing buildings, like the painter, like the stacker. So I went on to talk about how important it is to reduce this, and while I was giving that explanation, while I was looking at that, I said to myself, yeah, but I'm not actually following my own advice in this very moment, right? So what I did was try an asymmetrical approach. Let's simplify it a bit, okay? So let's get a stacker on here. And what I did was kind of go like this, right? So that you have one filter that is stuck directly to the stacker, and then the other one that only has one belt part, and you can have only one belt part of superfluous shapes or erroneous shapes that you will have to process through this stacker. So that cuts it in half, actually. And I talked a lot about how important symmetry was, but symmetry now I feel like is not actually that important, especially because of the bloody asymmetry of the filter in the first place. You know, you cannot mirror. You do not have a mirrored version of this filter, so it only has this belt going so, and then your trash going to the right, and you cannot mirror that. So I tried an asymmetric approach, and I think this actually this actually works better still, right? So let's get back to that. So I have, with the proper ratios in place, I have 8 machines, 8 stackers for one module. Right, and then it's the same principle. So the shapes are distributed as evenly as possible in the beginning, and then each belt will run into one of the stackers. And this is faster than when you have a serial stacking module. Maybe I didn't explain this sufficiently in my previous video. I talked about this when I saw the video by YouTuber Joe Mama 1973. So he called it a tuned exhaust and made a comparison with car engines. And in hindsight, I feel like I failed to explain what the system is. So if you have, let's just do this, right? So usually the most modules you find are linear, right? So you're going to work with stackers that are in linear fashion, something like this, right? So let's ignore the output for now, but usually it runs something like this, right? And with each machine, you're going to have a split. I'm sorry about that, clicked the wrong button. There we go. So with each machine, you're going to have a split, and 50% of whatever you have incoming in your belts, 50% of that will get to this stacker. And then of the remaining 50%, another 50% will move into this one. And the remaining 50%, half of that will go there, etc., etc., etc. And that means that by the time you get to the end of the line, it will take that machine a lot longer to get to the maximum amount of output it can get. Because first, the shapes will move here if they can. Whereas if you try to distribute your shapes and split your belts before that, and you have only 1/8 moving to this machine and 1/8 moving to this machine and 1/8 moving to this machine, etc., then you are going to be able to achieve your full belt a lot quicker. Right, so I hope that that's maybe a better explanation of what I have here. So every path you can take will move through exactly 3 splitters, right? And then it will move into the stacker with a filter attached to that, right? And that way I feel like this machine, this asymmetric machine, is a little bit faster than what it was before. Now, in the layout of my machine, I tried to make sure that this shape, sorry about that, that the bottom shape, in this case, the one that comes on the line where the filter is glued directly to the stacker, that is the shape that is produced first, because and this is a poor example. Right, let's look at another example. This is another poor example. There's another poor example. Jesus Christ. Let's find a good example. Yeah, here we go. So in this case, I tried to make sure that for all my machines, that this belt, the belt that's incoming on the right in this case, is the one that is ready first. Because when we have a change of shape, the backup is here and you can immediately throw that away. Whereas if this shape is the one that gets produced first, your backup will be here and you will still need to use these shapes. You will still need to output these shapes. So I tried to design my machines in a way that would reduce this risk as much as possible. Now, I believe there is no fail-safe way to do this, because you are dependent on which side for example, splitters are going to output to first, and you can't influence that as far as I'm aware. Right? And it also depends on what your previous shape was, what your next shape was, etc. So, what do we have then? Right. Then I have, due to the asymmetric approach, I have 3 filters on the, let's call it the left channel, right? So in this case, with the horizontal design, it's the top line, and then 2 filters on the bottom line. And what the filters do is the following. So the first filter is going to check, is the incoming shape correct? Is the incoming shape the one that we need for this stage of production? And if not, it's going to immediately trash it. The second filter, you see, is connected to a bypass lane. So what the second filter does, in both cases, is check, do we even need to use the stackers in this step of the process? And if not, it will move through the bypass lane. The bypass lane moves through the middle, and it will completely move past the entire stacking module, and it will move on to the next stacking level. And now the third filter, this is the third filter, and what this filter is going to do is it's going to block this line, the top line, if the bottom line is not yet up and running. So we will look at the wiring layer later, but basically this filter is connected to this belt reader, and if this belt reader has nothing moving across it, then this filter will be closed, right? That's the way that works. And that way I try to ensure that this side will never get backed up. right? And as I said, it's not fail-safe because it does depend on which shapes you had before and which shape comes after, etc. But I think in the long run, it will prove effective, right? So that's that. I think that's the physical layer. As you can see, I have my traffic light again. So let's look at the wiring layer again. Here is my main shape. It's on this wire. And again, this just moves all the way to the end of the machine, to the back of the machine. Here it is. There. Oh, sorry, wrong button again. This is it. Right, moves all the way to the back, all the way to the back, all the way to the back. Now, I did an interesting thing. I like to believe it's an interesting thing, but I kind of looked at which machines were the fastest. So, for example, if you look at this array, it's going to take a longer time for these shapes to move here than for these shapes to move here. So what I did in order to ensure, or try to ensure at least, that the bottom shape is always the quicker one, I actually swapped production. So the top layer is produced here if you just start unstacking your shape here. But as a matter of fact, what I did was I moved this through to my second layer, right? And the top layer is actually processed here. And then that way, that will move through everything. And the top layer will actually be done quicker than the bottom layer, right? Because the bottom layer will be the machine that's further away from the hub than the top layer. So I want to make sure that my top layer moves in first, due to what I explained before, so that you avoid as much backup as possible. So let's have a look at this. Here is the first split. It unstacks the top layer, and then that moves through a shape analyzer, which is going to split the color and the shape. And it's going to cut that up virtually so you have the correct quadrant. I rotate this so you have the correct quadrant. And I immediately have this smart system in place that I explained in my previous video before, that if you don't have an input, so let's cut this shape, for example. Let's cut this line, sorry. You still get a 0 output, and this will actually put all your filters to 0 rather than creating a void signal or a lack of signal, right? So that's what that does. Now let's look at the shapes first. So this is pretty simple. This shape is just moving through the filter, and it's going to, well, it's simply going to let the shape pass if it's the correct shape, and otherwise it will trash that. Now another big revelation I had, and I feel like I do need to mention this, is that your filters do in fact accept any input. In my previous machine, I was under the impression, I don't know why, it never occurred to me to test this, but I was under the impression that filters could only accept Boolean values, so zeros or ones. So, and in my previous machines, I was massively overcomplicating my wiring layer because I was always working with belt readers that would check the incoming input and then try to match that with the signal of the shape that we required, so I could transform that into a Boolean and connect that to the filters. And a huge part of why initially I didn't understand how Zachary's machines worked was because I didn't understand that filters can actually take any input, and they work. So you can put paint on your signal, you can put a shape on your signal, you can put a painted shape on your signal, and the filter will work. If that moves through the filter and it matches, then it will move. It will move straight through, and then otherwise it will be trashed, or move onto the secondary lane right here. So if you are a player like me who doesn't know this, there you go. My mind was blown. Right, so here we have our shape moving through. It moves through these this cascading module. So here you see this overflow thing in practice. If we have a full, in case we ever get a full storage of circle quadrants, then it would simply output the surplus here into this cascading little thing, and it would trash that. So maybe I don't know if we can show that, if we had that going on right here. No, we don't. Well, it doesn't really matter. So anyway, we have our shape here, our quadrant, and then at the end of all of this, I just hooked that up to a filter, and again, it's going to try and match that. In this case, it's the square quadrant, and that is the filter that will open up and move into the painters. So that's pretty simple, and you have a very similar thing going on for the paints. So here is my painting signal. It moves through all colors, checks that. Is it the color that we want? In this case, red, yes, it will open up, and red will start outputting through my machines. Now, a more complex setup in terms of wiring is here with these filters. So let's have a look at how that works. It's a nifty setup, I must say. So we have two serial color mixers, and if you have a primary color like magenta, which we see right now, then only this module will be used. And only if we have a tertiary color, which in this case is only white, because white is the only derived color from secondary colors, if we get white, then this module will be used. And the filtering that Zachary did, because this again is his design, I really have to commend him on it. The filtering that he did is pretty nifty. Now, I cleaned up his wiring. Well, I feel like I cleaned it up. I made it more transparent, I like to believe. But anyway, this is a system where any color combination is going to open up a corresponding set of filters as to move the primary and secondary colors and tertiary colors through these modules, right? So we have an incoming line, which in this case is cyan, and it's going to say, well, if in this case we need this filter to open up for green if we've got cyan, right? So it doesn't do that, and it keeps the other ones shut off. And for cyan, we also need blue. So, and that filter is located way up here, right? So this filter was here. Now, in the meantime, we switched to blue, and in that case, it's just going to bypass everything. It's going to use these filters, right? So this is a complex mechanic that for every potential color combination, it's going to open up a specific combination of filters as to output the correct shapes and the correct paints. And as I explained before, this mechanic will ensure that you can immediately start outputting the correct shape and then, the correct paint, and then it will be replenished while your machines are producing the shape. So that's how that works. Then we get to the painters. The painters are very similar compared to what I did before. So I have the incoming shape part right here. And it's just going to match that with these filters. If whatever comes through the filter is not the current shape that's on the wire, it's going to trash that, right? And we have the same thing for the paint. So that's these filters in the middle right here. That's for the paint. So if the shape doesn't match, if the paint doesn't match whatever's on the belt, then it will simply be trashed, and otherwise it will move through to the painters, right? And then I have what I like to believe is a smart virtual painter, which I did come up with myself. I'd like to credit myself for that. It's really easy, but essentially, if you don't have a signal, then this again will produce a 0 output, right? That's the way it works. So also on the virtual level, you've got the same thing going on. If your virtual machines don't get the proper input, or they get input on only one side, then they won't produce an output, right? This is for the virtual painter, this is for the virtual stacker, this is for the virtual everything. If you don't get a proper input on all possible connections, then you will not get an output. So again, if you have nothing on this lane, you will produce a 0 output, and everything that ensues, everything that follows, will still be trashed. All right. So sorry about that. Let's build the wires back in. There we go. And then at the end of my painting machine, I did connect the belt reader. So what is the belt reader going to do? It's going to affect this last filter. This is the bypass filter again, in case we do get a gray shape. So what does this do? If this is the shape we want, right? If this is still a previous shape or something, and it's not the shape we want, then this will produce a 0. Otherwise, it will produce a 1. And then I have the color comparer. So what it does is it's going to try and check, is the color that's coming in, or the signal, or the color signal that's coming in, is that gray, yes or no? If it's gray, then this will produce a 0. Because of the NOT gate, it will produce a 0 in our AND gate. This will produce a 1, and this means that only if we have the correct shape and it is gray, this filter will open, and in all other occasions it will be closed, right? So only if we have the correct shape and it's a gray shape, then this filter will open, and the shapes will be coming from the bottom instead of directly from the painters. Otherwise, it's going to close, and in the closed position, it's going to force the shapes into my painter, right? Okay, so let's now have a look at the wiring of my stackers. So we have the different filters that perform different functions the way I explained before. So the first filter is really easy. It's just there to check, are the shapes coming in at the top and at the bottom, are they what we need for this stage of production? And if not, it's just going to trash that. So the only thing you need here is run your signal and connect that to the filter. It does that at the top, it does that at the bottom. And then the second filters, this filter and this filter, they are the bypass filters. So they are going to check, do we have shapes on both sides of the aisle, on both sides of the stacker? And if not, the filter will be set to 0. And in practice, that'll mean that the shapes will move onto the bypass lane. So the wiring, I have an AND gate here, right? It just, if you have any signal coming in, then that will count as a 1, right? And we know, because of what I said, because of what I showed before, that if we don't actually have a shape, then we will get a 0 signal, right? Because we ensured that in the previous step. So either we get a shape output here, or we get a 0. And the result will be that this will be 0 if we have a missing signal on either side, and that will then open up both of these, or better yet, it will close these filters, right? And it will move here, and it will move on to the bypass lane, etc. And then finally, the third filter, I connected that with an AND OR gate, and in hindsight, I'm not really sure why I did that. But either way, this third filter, it's only going to open that up if we get a 1, and a 1 means that we have shapes moving through, so the bottom line is running, is producing shapes already, and only if it is producing shapes, then it will open up this filter, right? That's what's going on. So, and to ensure in cases that we have a tremendous amount of delay for whatever reason on the top layer, and this would start building up, that's why I built another storage with an overflow trash filter here, so that in case, let's just say this happens, right? Let's just say there is a tremendous delay for whatever reason on the top side, and this would back up all the way to my belt reader. Then this would eventually turn into a 0, and we would never be able to fire up this top layer again, right? Because the signal here would become a 0, and that is why I built in this this storage right here, and that's why I did that. Okay, so that's basically that. That's basically what it is. So what I then did was create in my wiring, because I had the space, I made another smart, what I like to call a smart stacker. So again, what it does is it's going to virtually stack the bottom and the top. And if either of both signals is missing, then this system, here is my stacked shape, this system together with this is going to ensure that the other shape will move through onto my final output wire. Right, so let's cut this. You will see that the shape that's being output, excuse me, oh right, no, that doesn't make any sense. If I cut it off here, you will see that the shape being output is actually the one that is moving, that is coming from here. That will be our output signal. So this way, my machine is actually capable of producing shapes that have a corner missing, right? Felt like that might be important to say, because a lot of Make Anything machines do not have that ability. They need quadrants on all sides. They need quarters on all corners to be able to process the shape. And if that's not the case, then, well, sorry, but you'll get stuck. So my machine won't actually do that. It can have corners missing. Now, I do want to maybe say that what my machine cannot do is produce the complex shapes, right? The ones that you need for your upgrades. There they are. So the one that is commonly referred to as the rocket shape and also the logo shape, my machine cannot do that. But you probably know this if you are at this stage of shapes.io, that you have to look at your shapes kind of like a layered cake, looking at it from the top. And if you have a layer that's empty, then the layers the layers stacked on top of that will actually fall down and move down a layer, right? And this machine is not capable of producing shapes that have empty layers, right? But it can be missing some corners, and the machine will still be able to output that, right? So the wiring is also gradually stacked with the stackers. So here I have the two inputs coming in, and they are virtually stacked here, just the same way the physical layer is, and then that layer moves through to the next stacker and will become the input for that machine, right? And this works in a chain. So again, this layer is then stacked, and it will serve as the input for the next machine, right? Again, that is stacked, etc., etc., and that way we move to the final machine. Okay, so during the entire explanation, I've actually already managed to get up to level 67, but I'm looking at the bottom right corner of my screen. My frame rate is at 17. I am going to try to boost that to 60 in another recording, similarly to what I did in my previous video. I first did the explanation, let it run a little bit, and then reattempted with a lot of different settings, a lot of performance settings reduced. I'm going to try to do that here too. And as I said before, your frame rate is actually influenced by what you're doing. If you move around on screen, then your frame rate will drop, at least in my experience. So I am currently recording this again with a secondary monitor attached, with an external microphone attached. I am at a tick rate of 60, as you can see. So again, I'm going to close it here. I'm going to wrap it up here. I'm going to reduce all these settings, and then in a second attempt, which in the video you will see in a few seconds, I will do the actual timed run. I will get the stopwatch again, and then we're going to see how quickly I can achieve those 100 levels. All right, see you in a bit. Hello again. Here we are in the same game, again at level 27, with what I'm starting to feel is becoming like my signature shape, but the game is now slimmed down in terms of all the performance options. Now, when I opened the game, my frame rate was all the way up at 60 FPS, so I was like, great, let's flip and do this. And then, as soon as I hit the record button of my screen capture program, the frame rate immediately dropped. So that means that my screen recording software does in fact have a strong effect on the game's frame rate, which is quite frustrating. But I guess this'll have to do, because this is simply the equipment I'm working with. I cannot do better than this. Now, because of what I said before, being that the frame rate is influenced by the movements you make, from now on this is going to be a stationary view centered on the hub. I'll do the same thing I did before, which is start the timer preemptively and build in the missing piece of wire at exactly 1 minute. Afterwards, we'll subtract the minute from our final tally, and that way we'll get a pretty accurate measurement. All right? A few more seconds to go. And off we go. And here we are again, closing in on the completion of level 126, after which we'll stop the timer and calculate the result. That's 125 done. Few seconds left. And there we go. The clock is at 1 hour, 14 minutes and 58 seconds. Now remember that we started the machine when the clock was at 1 minute, so we can still deduct that. Therefore, 1 hour, 13 minutes and 58 seconds divided by 100, which gives us 44 seconds and 38 cents. So we'll round it up to 45 seconds. And this means that, in fact, this new machine, taking the frame rate performance into account, is actually little over twice as fast as the previous one, which I would say is a win. Again, if you want to copy and modify any of these designs for your own purposes, feel free to do so. Now, usually, this is the time where any YouTuber goes, give this video a thumbs up, subscribe, and hit the bell for instant updates. But I am not that kind of guy. I play games only sporadically, and it's not my intention to grow my YouTube channel in terms of gaming content. So feel free to subscribe if you want, I won't stop you, but I am not sure at this stage whether I'll even make another Shapes.io video after this one. However, I would like to point out that all of the background music in this video is made by myself. I am a hobby musician, so if you liked what you heard and you would like to hear more, I cordially invite you to check out my music channel. Vince Music, spelled without spaces, and like and comment, subscribe away there. Alright? So I guess this is it for this video. I hope you had fun watching and I wish you all a lovely day. Bye bye.